Hello, my friends. We're going to learn today in this video about the chain rule. So the chain rule is the most powerful tool for taking derivatives. And once we know this, we can basically take the derivative of almost anything, which is pretty great. So the chain rule answers this question. How do I take a nested derivative? So not sine of x like we saw in the previous video, but what about the sine of 2x? How do I differentiate if there's something inside a set of parentheses besides just an x? Okay, and here's the basics of the chain rule. If you take the derivative of one function composed of another function, f of g of x, that derivative is equal to the derivative of the outer function, leaving the inside alone, times the chain, with the chain being the derivative of this inner function times g prime of x. So this is the chain, this is the derivative of the inside function that we're multiplying by. Okay, so this is an extremely powerful rule that we're going to use a lot this year for pretty much any time we take a derivative of anything complicated. So let's go ahead and just do several examples to show you some of the different contexts this can be in. But the main idea is you take the derivative of the outside and you leave that inside alone, and then you multiply it by the derivative of the inside at the end. So for example, suppose we differentiate sine of 2x. Now, using this notation, the sine is like your outer part, and the 2x, that's like your g and above, that's the inner part. So we start with the derivative of sine. So the derivative of sine is cosine. So we do cosine of 2x, and we leave the 2x alone. And then the chain rule at the back is telling us to multiply by the derivative of the inside, derivative of 2x, which is 2. So you could pull the 2 in front if you wrote it as 2 cosine 2x. Okay, so that's the basics of the chain rule. We're going to now look at several other examples here. So suppose, for example, we take sine of x raised to the 10th power. Okay, so here the inside is actually the sine. The outer part is the exponent. That's on the outside. So when you take the derivative, the first one that comes down is 10 sine of x to the 9th power times the derivative of sine, which is cosine of x. Okay, so there you go. And again, if you want to actually kind of make some guesses on this, when I put a problem up, feel free to pause the video, try and solve it on your own, and then compare to what I get. That might be a really good idea. Okay, so some other examples. Let's say we have the square root of x squared plus 1. Now, it might behoove you to write this as an exponent, like x squared plus 1 to the 1/2 power. Because then we have this inside that's clearly raised to power, so we can see the derivative. Okay, so the power comes down. That inner part, that x squared plus 1, stays the same to the negative 1/2. And then by the inside, we multiply by 2x, the derivative of x squared plus 1. A lot of the cool kids in this class notice that the 2's cancel, so we could write that as like x times x squared plus 1 to the negative 1/2. If you wanted to bring that down as root x squared plus 1, you can, but you don't feel you need to. This is perfectly acceptable. Okay, let's look at a case with e, because I think this is actually a pretty interesting one. So what if you have the function e to the 6x plus 3? Now, this is the inside. Think of whatever's in parentheses as the inner function. Your outer function in this case is just e to the x, which we know the derivative of that is just e to the x. Okay, so we're going to start with that. So we're going to start by taking the derivative of e to the 6x plus 3. So that'll start with e to the 6x plus 3. And then by the chain rule, we multiply by the derivative of 6x plus 3, so 6. So we could just write that as 6 times e to the 6x plus 3. Okay, so that's how we do those. One more thing, here's something we could have done with the quotient rule, but if you have something like this, you have to take the derivative of 1 over 2x plus 4, you can use the quotient rule. I find this type of problem a lot easier to just write as 2x plus 4 to the negative 1 power. And then for the derivative, you just bring that negative 1 down, right? So it's negative 1 times 2x plus 4 to the negative 2, and then the derivative of the inside is 2. You'll get the exact same thing from using the quotient rule if you simplify it. Okay, cool. So that's a little bit about that. Let's do one with a double chain, because sometimes you might have to do the chain rule twice. Okay, so we're going to start with our function f of x equals secant of e to the 2x cubed. Okay, so again, secant is my outer function, the e part is my inner. So when I take the derivative of this, the derivative of secant is secant tangent. So it's secant e to the 2x cubed times tangent e to the 2x cubed. And now here's where the chain rule is going to come in. I need to multiply by the derivative of the inside. So I need to multiply by the derivative of e to the 2x cubed. Okay, the derivative of e to the 2x cubed is e to the 2x cubed times, and here's where the chain rule comes in again. As part of taking the derivative of e to the 2x cubed, I need to take the derivative of 2x cubed. So I need to multiply it by another 6x squared. Okay, so that's like the derivative of 2x cubed. So we'd had to do the chain rule on the inside of the chain rule. But just start from the outside and work in. So we start with the derivative of secant, and then we work on the derivative of e to 2x cubed, and then we take the derivative of 2x cubed as our final step. So that's how you handle that. One more thing, of course, you might be combining the chain rule with a product rule or the quotient rule. So for example, say we have x squared plus 5 divided by cosine cubed of x. One thing I want to remind you about the notation, cosine cubed of x is equal to cosine of x raised to the third power. Okay, so when you take the derivative of that, let's see, low d high, so low d high minus high d low. Okay, so for the d low, this is where we have to use the chain rule on this cosine of x cubed. So the 3 comes down, so it's like 3 times cosine of x squared, and then by the chain rule, you multiply the derivative of the inside, the derivative of what's raised to that power, which is negative sine of x. Okay, and then of course we square the bottom, and away we go. So that's cosine of x to the 6th power then. I don't want to simplify this at all, so we'll just leave our answer in that form. Okay, so that's kind of the basics there of different ways the chain rule will come up. I want to again look at kind of some symbolic examples here. So just dealing with like an f of x and a g of x. You guys really love these problems. So for example, say I ask you to take the derivative of y equals cosine of f of x in terms of f and f prime. Okay, so when I do that, my derivative would be negative sine of f of x times the derivative of f, so times an f prime of x. Okay. Again, I really want us to kind of build comfort with these. We see them on the homework. You'll see them on the AP test, just working with like an f and a g. Let's look for another example. Suppose I give you g of x. So this is a case where like one function is eating another function. So again, you have like your outer here and you have your inner here, but you're still following through the same process. So the derivative of the outer is g prime of g of x times the derivative of the inside, so times g prime of x. Okay, so it's just in terms of g and g prime. One thing to remember, this g prime of g of x, it's not like g prime times g, it's g prime of g. Okay, so let me give you one more example using the chain rule. Okay, so the chain rule with, I don't know why I wrote that again, the chain rule with f and g. So suppose I tell you that h of x equals f of g of x, and I ask you to find h prime of 3 given the following information. So I'm going to give you some values here. So I'm going to say f of 1 is negative 3. F prime of 1 is 2. F prime of 3 is 8. G of 3 is 1. G prime of 3 is 7. We're not going to use all these values, but okay. So just like any other problem where you have derivatives, it's 2 steps. You need to take the derivative and then you need to plug in. Okay, so h equals f of g of x. So when you take a derivative, h prime is f prime of g of x. And then you multiply by the derivative of the inside, so times g prime of x. Okay, now let's plug in. So h prime of 3 is f prime of g of 3 times g prime of 3. Again, one of the most common mistakes I see is people think like this is not f prime times g. It's f prime of g of x, f prime of g. Okay, so that I think is important here. So this is going to be f prime of, what's g of 3? Well, it's right there, it's 1. So it's f prime of 1 times g prime of 3, which is 7. So it's f prime of 1 times 7. F prime of 1, the problem tells me, is 2. So this becomes 2 times 7, which is 14. Okay, so that's how you deal with that problem. Just be careful. Come up with like this symbolic derivative first in terms of f and g before you plug in. Okay, just one more quick thing I wanted to mention. Second and third and more derivatives. So sometimes you might see this kind of notation. When you see like this f double prime of x, or sometimes you'll see this notation like d squared y dx squared, what that is that means the second derivative. And the second derivative is just the derivative of f prime. So it's the derivative of the derivative. So for example, like if I tell you f equals sine of x squared over 2. Well, the derivative of that, derivative of sines cosines, that's cosine of x squared over 2 times the derivative of the inside, which is times an x. So now if you want to get to the second derivative, again, that's the derivative of f prime. Looks like I'm going to have to use the product rule here. So that'll be first times derivative of the second plus the second times derivative of the first. So negative sine of x squared over 2 times x. Okay, and you can see that this is going to kind of get out of hand in a hurry. If you wanted to take it a step further, right, the third derivative, which sometimes you'll see written as d cubed y dx cubed, it's a weird notation we'll talk more about later, would just be the derivative of the second derivative, so the derivative of f double prime. The fourth derivative would be the derivative of the third derivative. The 10th derivative is the derivative of the 9th. Okay, so those are some higher order derivatives. That was the chain rule. I hope this helps. As always, hit me up if you got questions. I'll see you guys soon.